All right. Good morning, everybody. How's everybody doing? Good. Are there any questions about what we discussed yesterday or the exam? Anything I can answer for you? Okay, so that's not working. Hold on. Hello? Can somebody who's remote confirm that they can hear me? Okay, thank you, everybody. All right, so any questions in case you didn't hear me last time? Is that it? Yes.
Will there be like diagrams like this on the exam?
No, we won't ask you to draw a diagram. It's kind of difficult to do that on Canvas using whatever you have to draw. So it's likely, it's possible that for a question, we give you a diagram in order to explain part of the question, but we don't expect you to draw a diagram as part of your answer. Okay. Let's see. Luke, go ahead.
So will we be writing code on Canvas?
You will be writing code on Canvas. And so you are, as I said yesterday, you are free to use Eclipse. So you can write code in Eclipse, and when you're done with the answer, just paste it in the answer box on Canvas. But yes, on Canvas, it'll just be for the questions that ask you to write code, it'll just be the question followed by a large text box for you to paste the answer.
You said there will also be a professor during the exam, so you can ask questions. How do we contact the professor? Through Teams?
I'll let you know. Yes, it will be through Teams, but I will let you know what is the way to do that. Most likely, it will be the Teams for the team that has all the sections in it, because we would have students from multiple sections taking the exam together. But I will let you know. We need to talk about it amongst professors, and then we'll post on Piazza, and I'll let you know. Yes?
Are we expected to abstract everything?
Are we expected to abstract everything? Well, if the question asks you, then yes. Okay. If the question doesn't come around right out and ask you, but you feel there is need for an abstraction, then yes, we expect you to do it. Sorry, Robert, where's the practice exam? The practice exam is on Piazza. The Professor Razak made a Piazza post yesterday, posting the practice exam. Since we are typing on Canvas, will style be checked? No, we will not run any auto graders on your exam. Having said that, we expect you to write code that is indented. Please don't give us code that all starts at column 1. It's incredibly hard to read. Besides it being annoying, because when you give us something that's harder to read, that increases the chances that we miss something when that you have written, or something that you're trying to do, we miss it simply because the code is unreadable. If you're using Eclipse and just pasting your answers, the indentation shouldn't be a problem, so long as it looks indented on Eclipse. Okay. Anything else? Going once, going twice. All right. So let's start today's lecture. So today we're going to work with a list. Just to kind of mix it up, I've made it a list of something different. This is going to be a list of runners. So you can imagine somebody keeping track of a list for a race that they are organizing, perhaps the Boston Marathon. And so we have The list class we have the list implemented using the familiar ILO interface and conslow and emptyLO classes, as you see here on the screen. It is a list of runners, and so we are keeping the name, the position of the runner in the race, whether the runner is male or female. Once again, we are resorting to a rather simplistic way to represent gender here, just in the interest of time. The age of the runner and the time it took for the runner in seconds to reach the finish line. Okay, so we are keeping that data for every runner, and we wish to write methods like these on the list of runners, things that we might want to know about the data, given the data that we have. So find all the male runners in this race. Find all the female runners in this race. Find the first 50 runners by position. Who are the first 50 people who finished the race? Find all female runners over the age of 50. Okay. So in order to write these methods, let's pick on one and then kind of write it and then see where we go. Now, I will say this, I will start this by prefacing that we have seen methods like this before. When we wrote the list of books, one of the methods we wrote was give me a list of all books that cost less than $20, if you remember that. So in spirit, these methods seem similar to that. Okay, so the code that we'll write is going to be similar. So let's go ahead and write one of these. So I'll pick all male runners. Okay, so here is my cons case, and so it's going to be public ILO runner, all male runners. Okay, so if you remember how we designed that give me all the books that cost below $20, we basically asked ourselves, okay, we are in the cons case. Does this book cost less than $20? And so similarly here, we would need to ask, is this runner male? If so, we need to include this runner in the result that we return. If this runner is not male, then we do not include it. Okay? So stating this in plain language, as we've been doing all semester, the list of all male runners starting from this list is, if this runner is male, then it is this runner followed by all the male runners from the rest of this list. If this runner is not male, then it is simply all the male runners in the rest of this list. Okay? Does everybody follow? All right, so all that needs to be done is actually write out what I said. And so if this runner is male, now in the runner class here, we are keeping track of that information. There's a Boolean called is male. Okay? And so we say this dot first is male. If the runner is male, then we return a list that starts with this runner. Oops. Followed by all the male runners in the rest of this list. And if this runner isn't male, then we simply return all the male runners in the rest of this list. So you can compare this structure to give me the list of all books that were below $20, and you will find that the structure is very similar. right? The empty case, let me write it out here. If this list is empty, then the list of runners, list of all male runners in this list is also an empty list. New empty low runner. Okay. Just so we have an example in front of our eyes as to how we are going to use these methods in a test. So in our examples, okay, somewhere in there is going to be, so ILO runners, all runners. And here's where we create all our runners, and then male runners will simply be all runners dot all male runners. Okay. So that's how we would come up with this example. Victoria, isn't this dot first dot is male a field of a field? Exactly. Good, you spotted it. So in spirit, in concept, this is correct. But of course, our problem is this right here. It is a field of a parameter, which is not allowed. It's a field of a field, I'm sorry, which is not allowed. Okay. So how do we get around this problem? Every time we have a field of a field, we are going beyond an arm's length reach. So how do we get out of this situation? What's our way out? Make a method that determines if the runner is male, or ask the runner to give you the answer, are you male? Okay. And so we can change this by saying this dot first dot, whoops, is male or is male. You can call a method on a field. That should be part of your template. Okay. So this is something we wish for. And so in the runner class, we would write a method called isMale. And that's how we would get around it. Okay? Let's tackle the first 50 runners. Okay? All female is going to be very, very similar. All you need to do, in fact, is since isMale is Boolean, just put a not in there for all female runners. Okay? You will notice, though, that when we write all female runners, it's going to be very, very similar to this. In fact, the only difference is going to be there is a not inside that if statement. Okay? So we just came up with two methods that look very, very similar to each other. But that's because we might say, well, that's because they're asking very similar questions. One is saying, give me all the male runners. One is saying, give me all the female runners. And our representation of gender is Boolean, which means literally what is in one is not in the other. Okay? But let's tackle the first 50 runners. What is first 50 runners? Yeah. So first 50 runners are simply the runners that have the first 50 positions. when you finish the race. And so once again, we see that the runner class keeps track of the position of the runner. And so the list containing the first 50 runners either includes this runner or does not include this runner. It includes this runner if this runner's position happens to be less than or equal to 50. Otherwise, it does not include it. Okay? How we decide to include or not include, how we make it happen is going to be largely the structure. And so if this dot first is the position below or is the position at or below 50. Okay, so this time I'm done directly anticipating that I may need a field of field. And so instead of that, I'm writing a method. Okay, directly I could have written this dot first dot pause less than or equal to 50. But this dot first dot pause would again be a field of field. So instead, I have a method right there. Okay, and if this is the case, then I return a list that has this runner followed by the runners in the first 50 positions from the rest of this list. Otherwise, I do not include this runner, and so it is simply first 50 runners. Okay, and again, the list of runners in the first 50 positions in an empty list of runners is an empty list of runners. So the empty implementation of this is going to be very similar to the all male runners that we have. Okay, not allowed to do that. Let's see. Make a method that determines if a runner is male. This is the non-accumulator way of solving the problem. Yes, this is, Victoria, the non-accumulator way. You could have an accumulator way that keeps accumulating all the runners that are in here. And so if it passes that Boolean, then you call this dot runner dot first 50 runners help, and the accumulator you pass to it is going to include this runner. Yes, so that would be the accumulator way of doing this. Okay? So we haven't really said anything that we didn't say before. As I said, we have seen this kind of a method before. But let's look at these two methods that we wrote. And the all female runners, which we already said is going to be very similar to that all male runners. So it's not difficult to see that these two methods are very similar to each other. Okay? However, it's a different kind of similarity than what we have seen before. To be sure, the structure is similar in that what it is trying to do is similar, but what is different about each one is obviously this one calls itself, and this one calls itself. So they call themselves on the rest of this list. But obviously, because there are two different methods, the first method calls itself on the rest of the list. The second method calls itself on the rest of the list. So as far as comparing code is concerned, they are not identical. They are nowhere close to being identical. But there is similarity in their structure. Each method calls itself on the rest of the list. The second similarity is this right here. Oops. This right here. And this. There are obviously different methods in the runner class, but there's similarity between them. Each one of them is trying to find out something about the runner. Okay. Moreover, we are sticking that inside an if statement, which means another thing that's similar between them is that both of them return a Boolean. So you might characterize each one of these methods as does this runner qualify? In the first thing, qualifying means is this runner male. In the second method, qualifying means is this runner's position in the first 50. But at a higher level, we can say both of them are basically asking a question whether this runner qualifies whatever it is that we want this method to be, whatever it is that this method seems to be identifying about runners. Okay? So there is similarity, there is structure. If something, then return a list that includes this. Otherwise, don't include this. So that part is identical. Both of them use a test of sorts to find out whether this runner qualifies. And they call their own versions. Now, if you look ahead to all the other methods, all female runners obviously is going to be a helper like this.first.is female. Or you could just say not of this.first.is male. Okay? All female over 50. Once again, you're going to say, does this runner qualify? This runner qualifies if this runner is female and this runner is over 50. So you're checking for two things, but basically, you're checking if this runner qualifies. And the answer to that question is yes or no, true or false. Okay? So how do we leverage this similarity in structure in order to do abstraction? This is slightly different from the cases for abstraction that we have seen thus far, because the code is not, forget being identical, the code is line for line, not even similar. But the structure is similar. The kinds of things we are doing in pieces are similar. So the answer to this cannot be try to make them identical and then lift the method into the abstract class. That is not going to work, because we will never be able to make them identical. And yet we have to try to do this. So how does one do this? So let's tackle that test first. Okay? If I write these methods in a way that kind of captures this, oops, I'm basically trying to write a method. So let me try to unify them. I'll just call it find sum. Okay? And so the structure is if this dot runner, this dot first, qualifies, then I'm going to return a new cons low runner with this dot first, followed by this dot rest dot find sum. Oops, too many. Otherwise, return this dot rest dot find sum. Okay, so if you compare this to the structure of either of those methods, I've tried to generalize it in some way. I've just called a method called find sum. Okay, this is just to capture the common things between them. This is not obviously all Java code because of what I've done in that if statement. But this method captures the structure of both of those both of the methods that we actually wrote. Okay. Obviously, so this has captured what I've marked in pink over there, that the method calls itself. This has also captured what I want to do in this if statement. So it is possible to replace those two methods with some version of this method over here. But we have to complete it. The main problem we have to solve is, how do I express this? This dot first qualifies. So our way in both the above methods is to write helpers inside the runner class. Is male runner, is male first 50 runners, is pause at or below, is female, blah, blah, blah. Okay? This is inefficient because for every method like this that we think of a list of runners, we have to add a corresponding helper method inside the runner class. Okay? For every one of these methods we wrote in conslow runner, we needed to write in another method in the runner. So let's try to turn that on its head and say, well, instead of writing a method inside the runner class that returns a Boolean saying, does this runner qualify? What if I write a method outside that runner class? So like this. I would have a method called, I would have a method that returns a Boolean and say is male runner. But I don't write this inside the runner class. I make this method take in the runner that I am going to find out if it is male or not. Okay? And here I can do things like r dot is male. Field on a parameter is okay. Field of a field is not okay. So I can write a method like this. Okay? And now, here's the part where, perhaps for the first time in the semester, I wish I was in Racket. Because what I want to do is take this method from here and somehow try to put it over there. Because that's really what I want to do over there. Or I wish I could pass this method as an argument to this method right here. And then inside that if statement, I could merely say, okay, run the method that I just gave. Okay? So this had a specific name in Fundies 1. What was that name? Somebody has their mics. Ivan, could you mute yourself?
Oh, sorry.
Luke.
I believe it's called higher order functions.
It's a higher order function. Does everybody remember that term from Fundies 1? A higher order function is nothing but a function that takes as a parameter another function. Okay? And why would we do that? Well, in this case, if such a method could be given as a parameter to this find sum, then I can call that method over here. So what we really need is a way to write a higher order function in Java. Unfortunately, unlike Racket, Java will not allow us to pass a method as if it were an object as a parameter. It doesn't do that. Okay? So what we have to do is kind of dupe Java into thinking that what we are giving it is an object, when indeed the only thing inside that object is that method that we wanted to pass all along. In other words, we sort of gift wrap this method. Pretend that it's really inside a class. I'll call it runner male test. Okay? And then right here, I could make it take in a runner male test. Okay? And then is male runner. So I could replace this statement by saying R dot is mail runner. With first. Okay. So what is that runner mail test? It is simply an object that contains inside it a method. And so inside this class, inside this method, I can call that method isMailRunner and pass it this dot first. Okay, you had a question?
Yeah, I guess, is there like any particular reason why like Java wouldn't have any kind of functionality that would make this process like easier? Like it kind of seems like a little, like I'm not sure the word for it, but like it seems kind of like a jerry-riggy to kind of create a class that really is just doing that.
Correct, correct. So the question is, isn't there a way to do this in an easier way in Java? Because it seems like I'll describe it more euphemistically. You have to jump through unnecessary hoops just to get it to work. Right. And the reason for why we must do this is simply not what Java was made for. Higher order functions, the ability to pass a function as if it were a data, like a parameter to another function, is a staple of what we call functional programming. It happens all the time in functional programming. Racket is a functional programming language, along with many others. Java, on the other hand, is made to be an object-oriented language. What does that mean? Well, we have seen that one of the aspects of object-oriented languages is that a class is supposed to be a combination of the data along with methods that operate on that data. Okay? What that means is, if you look at things from a purely OO way, a method or a function cannot exist in isolation. It has to be existing within the context of a class. So there's simply, if you're pure about OO, there's simply no place for a function that's just kind of floating around without being in a class. Java is based on that philosophy. And that philosophy, as we are just saying, in some ways fundamentally conflicts with kind of this more hippier way of thinking that anything goes. Oh, a function is a function. A function is also something you can pass as a parameter to others. Okay? And so some amount of gift wrapping, some amount of faking is necessary to make this old dog do that new trick. There are ways to make it better than what I have written it, and we'll progressively get to that though. Okay? All right. So does everybody understand where we are going with this? So this is slightly better, but again, the hope is that we write this one method that does the job of both of them. And so if we write a different test, this was the mail. If we write first 50 runners, that would be another class like this, which would have a completely different method inside it. And therefore, again, we run into the same problem. We need to be able to call a common method here. So now we can say, if we write that second one, class runner first 50. And then we can say Boolean is runner in first 50. And you take in the runner and you say return r dot pause less than or equal to 50. This is what that other class would look like. And once again, we run into the problem because they are two completely different classes. It would be nice if we wrote both classes such that the name of the method inside it would be exactly the same. Because everything else about those methods is exactly the same. Both of them return a Boolean. Both of them take a single argument of type runner. Okay? So why not name both of them the same? So let me change this so that I call it, well, it's a test that I'm applying to this runner. It's a test that I'm applying to this runner. Okay? How does this help me? Well, because the method name is the same both places, I can now say apply right here. Let me rearrange that so that it looks better. If r.apply this dot first. Okay, so at least there's one method name that can capture everything. Okay, the other minor quibble is what do I use as the type here? Because clearly these are two different class names. Both of these classes have a method whose signature is identical. It's called apply. It takes one parameter of type runner. It returns a Boolean. I know that there are other versions of this coming. So why not create something that will have a method like this so that all these classes would have to implement that same method? And so what I can do is I can create an interface for this. I can say interface runner test. Okay, and in here I write the signature of that method I'm trying to look for. All right, and then here I say this one implements runner test. And similarly, so this becomes a public. And similarly, this one implements runner test. And this becomes a public. That way, I can write this method so that it takes in a runner test object. Okay, so the runner test is now an interface. The interface has a single method called apply. That method takes in exactly one parameter of type runner and returns a Boolean. Okay, because it's an interface, I can use that type here, and I can call this method by passing it different implementations of that same interface. And now finally, I can have this method do the work of the two above methods. All right. Stephen says, why couldn't these qualifier methods all be in the same class? Class runner test that contains both Ismail runner and is first 50 runner. Okay, good suggestion. So the question is, why did we need to write separate classes here? So let's imagine that we wrote one class that had multiple of these Boolean methods. Okay. Then right here for the first method, I could take in an object of that class, and then I would call this dot. I could call one of those methods in here. For the second method, it would take an object of again the same class, but I would call a different method here. So I could do that, but that does not fulfill my objective of somehow replacing these two methods with a more standard version method like this. Because inside that if statement, I would still have to call two differently named methods. If I add a third method in that class, I would have to write still a third different method here that is very similar, except I call a different method in the if statement. So I'm not able to kind of abstract them out. Wouldn't it be better to keep the different method names instead of using a single apply because it is more readable? Now you won't know what the code is doing unless you run it through the debugger. Good point, but I'm not done yet. So once this is done, my test now looks different. My test is no longer all male runners. My test is going to be find some And then in here, I wanted to find all male runners. So I'm going to pass it an object. What was the method I had? Male runner male test. It was a poor naming case. Runner name test, runner male test, right there. Okay. So now by looking at the example, I know exactly which method I'm calling or which class I'm calling. I'm differentiating not by a different method name, but by a different class whose object I'm passing to this method. So I want to get first 50 runners. Before I had to say all runners dot and call some other separate method. Now I can call the same method, find some new, and this time it is going to be that other class that implements my interface, runner first 50. First 50. So you see which one of those methods is running, which test am I running on every runner is differentiated by which exact object I'm passing to this method, find some. Okay. Stephen asks, why do you need an interface in two classes instead of one class with multiple methods? Again, the same thing. If I had only one class with multiple methods, I could not use the same method here. I could not call the same method here because I would still have to write these two methods separately in my cons low. And then both of them would take the same object as a parameter, but call a different method. Okay. All right. Questions? So I no longer need these two. I replaced it with this one method here. Okay. And that runner test, let's try to articulate the purpose of this interface and these two classes. The purpose of this interface is just one. It represents a standard kind of test that I am hoping to run on a runner. Okay? And so that is like you want to create a test to pass find some. That test must implement that interface. In other words, that class must have a method whose signature is exactly this. So now you want to find a list of all female runners over 50. Great. What you need to do is you can create a third class that implements runner test. And in its apply method, you can say return r dot not of r dot is male and r dot age greater than or equal to 50. And so all it will take is a third class like this that implements that interface. And then in the examples, you just call the same find some method, but pass it an object of this third class in there. So we do not have to write separate methods for each one of these cases in my cons and empty. I write just one, find some. But then I call it and pass it different tests depending on what kind of a list I need. Okay? Questions? Yes?
So what do you do with find some? Like, when you call it virtually, you just literally the same thing that it takes. Like, you don't change it at all?
I do, here, right here.
Or like, not in the examples, in like the actual code part?
In the actual code part, I've written it just once, and it takes an object of that interface.
Yeah, but when you cover virtually on like the rest of them.
Yep, okay. So I do have to change that. So because this method now takes an argument, I will just pass it the same. I will just pass it the same argument that was passed to me. Think of that object as a little box that contains a test in it or a runner. Okay? And so I apply that test to this runner to see if it qualifies or not. And whether it does or not, I do one of those two things. Okay? So any object that I'm passing in here, which I've shown you two examples, this example right here, or this example right here. To be sure, they are objects. You can clearly see that they're objects. But those objects have exactly one method in it. So I called it a gift wrap because that's exactly what it is. You can imagine writing a method and then gift wrapping it in a box so that you can hand it over to a method. Okay? So such objects that really exist only to enclose a method inside it are called function objects. That's all there is to it. Function objects are most popularly represented by an interface that contains only one method in it, as our interface does over here. Okay? In this case, our function object is something more specific. And it is characterized by what function it actually encloses. It encloses a function that runs on a runner and returns a Boolean. So there's a name given to functions that work on one thing and return an answer that's yes or no. Such things are called predicate functions. Okay? So this function object is a predicate object, but only because of the kind of method that we wrote on it. Okay? So you could name this runner predicate. If you wanted to. Questions? So I motivated that all female over 50. So one of the ways you could do that is by writing a class like this and then in the return statement have an and statement. But you can do one better. Here's an alternative way. You can write a class that represents the and of two qualifying tests in general. So you can say this class is an and predicate. And runner predicate, I should say. That implements runner test. Okay? And now it is capable of taking two runner tests and returning the and of whatever their apply methods return. Okay? And so I'm going to store those runner tests as fields. I'm going to write a constructor for them that takes in the two tests and just assigns them here. And now my apply method is simply going to return the result of the first predicate and the result of the second predicate. The advantage of this is now this class can represent an and of any two runner tests. So if I have more than one case where I need to say, okay, this runner qualifies if this is true and this is true, I don't have to write separate implementations of runner predicate anymore. I can just grab two existing runner predicate objects and put them through an and predicate, and then use that and pass that to find sum. Okay, so this represents yet another possibly minor but important abstraction. I'm not having to write multiple classes, all of which are basically doing an AND on two conditions. Okay, and if your test involves an OR, you write another one called an OR predicate that does virtually everything except here instead of an AND there would be an OR. Okay? Questions? So let's see how many people remember. This method that we have written, find sum, is going to work on a list of runners. It is returning me a list of runners, and the list it returns me contains some, but possibly not all the runners in the original list. So if I had a list of runners of 50 runners, and then I say, how many, return me all the male runners. So I call find sum and I pass it the male runner predicate test. It is returning me, let's say, 25 runner objects. Each of those 25 runner objects are part of the original list of 50. So it's starting from the original list and returning me possibly a subset of that list. What is such a method called? Yes?
Filter.
It's a filter, exactly. So what we have just seen, what we have just implemented is a filter on list of runners. Okay? We haven't quite yet learned how we are going to make a list of anything we want. We create a separate ILO for every kind of list. In about 2 or 3 lectures, we're going to find a way how to write one definitive ILO and conslow that will work with any other class. And at that point, we can write a true filter on a list. But this is a filter on the list of runners. The return me all the prices, return me all the books below $20 was a filter on the list of books. So this is what a filter looks like in Java. Okay, so a better name for that find sum might be filter, because that's what this method is. All right, now I want to concentrate on how I'm calling this method. To answer your question, is there a less hacky way? Is there a less verbose way of doing everything that I just did? Okay, so I'm going to concentrate on that particular way. These are features, some of which are available in Java, have been available in Java for a while, and there are other, and then I will show you something that is a relatively new addition. When I say relatively new, I still mean 4 years ago, but Java itself is 25 years old, so it's relatively new. Okay, so I'm going to replicate what I just wrote over there. Male runners equals all runners dot find sum, and then I pass it a new runner male test. Okay, this is how I called this method before. Now, is there scope for cutting down on the red tape and cutting down on the gift wrapping if possible? So the first thing I will point you to is the fact that it is quite possible that this method, this class is used only here when you're actually trying to use it. So it seems wasteful that for every test that we have to write a separate class somewhere, only to create an object of that class the one time in my example. This may or may not always apply. You may have several cases where you're using that runner male test, in which case what you have done till now is enough. Shouldn't go ahead. But every so often you come across classes like these that you wrote it, and you're instantiating them only once somewhere. In that case, it seems wasteful to write a separate class only to use it one time here. So what Java allows me to do is kind of write the class at the place it is being used. Okay? And when I do that, I don't have to give the class a name. Hence, these are called anonymous classes. Okay? Here's how I would do. Now, what I'm providing here is a runner mail test, but what I'm really providing here is the object of a class that implements that runner test interface. Okay? So Java allows me to do something like this. It allows me to say, and I will warn you, the code will look messier and probably and possibly more confusing, but stick with me here. I will say new followed by the name of the interface. So normally this is absurd. You cannot create an object of an interface. There's nothing there. Okay? So you do that, and then in here, you dump the entire code of the class that you were supposed to write. So what goes in this class? Public Boolean apply runner R return R dot is main. So all I've done is I've just put the contents of that entire class right in here between these two curly braces. Okay. Now this looks messy because it seems that in the middle of that call, within parentheses, I'm defining an entire class. Okay. So you have to use this feature very, very sparingly. It is useful only when the class in question is instantiated only once, and the class in question is extremely short and simple. Like in this case, it had one method in it, no fields, no constructors that I had to write, and the one method I had in it had only one line of code. But I could do this, and then I need not write that class at all. And why does this work? Because that find_some method ultimately is looking for a runner test object, an object of a class that implements the runner test interface. And so that's what I've directly provided it. Okay? So these are called anonymous classes. Class without a name. Notice, no name. That runner test is the name of the interface. Okay? So I've cut down on some red tape because I need not write a separate class anymore. But I can do more, because at the end of the day, what does find_some really need? Yes, it needs an object of the interface runner test. But that object contains only one method in it. Okay? So there are about 100 people in this section. So when I need to talk to one of you, I need to know your name, or at least point in your direction. If there was only one person in this class, I would never need to know that name, that person's name. I would just say, hey, you, do something, right? In this object, there's only one method. That is the only method that can be called on this object. So much like I got away by not naming the class itself, I can get away by not naming the method either. Just saying, hey, here's an object, call the one and only method that happens to be inside this object. And that should be enough. Okay? So in addition to the class being unnamed, now I'm making the method in that class also unnamed. This does have a method that you have heard before in Fundies 1. What are these methods called that have no name? Lambda functions. So as it turns out, starting Java 8, you can write Lambda functions in Java. Okay? How do you do that? So in this case, I'm going to say all runners dot find_some. And yes, I need to provide it an object, but the only thing inside that object is going to be a method called apply. That's the only method inside that object. Okay? So I can remove that new runner test part at all. Okay? Furthermore, since there's only one method, I can completely skip naming that method. So the public Boolean apply also goes away. Apply is the name. It does take in one argument. So I start with that. Okay? And traditionally, I would say open brace, close brace, and that return is r.isMail. Because this is a lambda function, I use a slightly different notation. I say hyphen greater than sign. And then within the braces, I say return r.isMail. Okay? But since FindSum is looking for a runner test, which is an interface that contains exactly one method, that method is called apply. It also can know from that interface that that method is supposed to take one single parameter of type runner, which means I don't need to specify the type either. And now since there's only one parameter to that method, only in this case, there's only one parameter to that method, I can also skip the parentheses. Okay? And now, all I'm doing inside this method is grabbing a field of that, doing one thing in there, and returning whatever the result of that thing is, which means I can cut down more red tape. It has only one line in it, so no braces. And since I'm returning whatever that one thing is, no return. And so the grand total of everything becomes r.isMail. That's it. This looks suspiciously like what you write in your purpose statement in bracket. Number to something. This is runner to Boolean, literally in that notation. Okay? This is valid Java syntax. This is what a lambda function looks like. In Java. Okay? Compare this to the anonymous class, but more importantly, compare it to this. Instead of this, you could have just said that. You still need the interface name. You still need to define the runner test. You do not need to write all those classes. That right there is the implementation of those classes. Do you need the parentheses after isMail to call the function? So isMail is not a function in this case. IsMail is directly the field of that thing. But you're right. If I was instead calling a function that returned a Boolean, you would need those parentheses. Yes. And you cannot skip the braces if you are doing more than one line of code. In this case, it was a one-liner, so I could skip the opening and closing braces. Okay? Questions? Yes?
Is there a reason we didn't name the runner test interface with an I first?
No, there's no reason. I just named it that way. So you could call it an I runner predicate to be more accurate about what it actually is. So this won't be on the midterm, right? No. In fact, this is all what I call syntactic sugar. Anonymous classes and lambda functions bring absolutely no new functionality to Java. They're just a shorter way of writing things, which means you can go through life programming in Java never knowing that these even exist. But you already know what a lambda function is. And Java now already supports writing lambda functions. Here's how you do it. Okay? But this is not necessary by any means on the midterm, on most of the assignments, unless we say otherwise. Okay, so this is pure syntactic sugar. This is for you to know for your own benefit. That's it. If you never like Lambda functions, was never a fan, and the syntax is too awkward, feel free to ignore it. But if you were intrigued and this does appeal to you, feel free to use it. Okay, so with that, we'll stop. Turns out we can do things like this for other methods that we have seen. For example, we sorted our books by price. What if we wanted to sort them by their titles? What if we wanted to sort them by the names of their authors? Again, we would see a lot of similarity, and we can write higher order functions on them. That's what we will do tomorrow. Okay? See you, everybody. See you next week. By tomorrow, I mean next week.